Welcome, public inventors. Here at Public Invention for All Humanity, we have the principle of documenting everything we're doing. So I'm making this video, even though what I'm going to show you is not very impressive. I wanted to give you a status update on the Gluss Pusher project. I have made some progress since my last video. I 3D printed a new stator design, which is much better. As I mentioned before, I was having a problem where the position of the push rod was uneven, and that was because I had foolishly miscalculated the distance between the coils, so they did not match the magnets, and that's kind of silly mistake. I can only say that this is my first experience with 3D modeling software. I was using Autodesk Fusion 360 to design these pieces. This basic piece, I have two of them now. I've wrapped with coils and magnet wire and reproduced my setup. Previously I mentioned that I thought I had a good way of doing the sensing, and that seems to have panned out, although I have not made full use of it yet. You can see a slight glow over here of the LED that I'm using to shine down the tube. It uses a simple white light LED controlled by the Arduino system over here. I don't actually have two Arduinos, I just needed some extra breadboard space. And then that is fed into a photoresistor, which I measure with this photo dividing circuit to do calibration to sense the position of the rod. The fundamental weakness of this system right now is that it's not very reliable, and I wanted a robust system that could tell when it had not worked. The other problem is that it's not as forceful as I would like it to be. So with the calibration system, I now have a way of telling absolutely what position I'm in. I'm going to sort of demonstrate how that works right now. So I'm using a Mac hooked up to the Arduino to control it, and I built a little controller. I enter the command to calibrate it when I have the correct port on my computer, and it starts a calibration procedure. It's going to bring it into the fully retracted mode, which it can tell based on the sensor, and then it's going to move out in half-step instruments, recording the voltage from the sensor at each point. That then goes into a table which can be stored in the EEPROM of the Arduino. You may be able to see that on my screen. I'll edit it in later. And hopefully that will allow us to make the whole system more robust. As you can see, it moves relatively slowly right now. That's because of the danger of overshoot. With the position sensor, I should be able to tell precisely when the rod has moved to a correct position to turn on one of the coils or to turn off one of the coils to provide braking forces. So we should be able to get much faster and much more robust movement in the future. I'd like to point out that I'm not terribly happy with this physical design. You may recall that the push rod, which is a carbon fiber rod like this, has a series of magnets in it, like this. And the problem is the end cap, which I also 3D printed, this tiny little end cap, and there's another one of those inside the acrylic tube here, seems to be very sticky. And I think that's just an example of poor mechanical design on my part. This is a relatively long space for a rod to be inside it, and any torque at all kind of tends to bind. And for some reason, acrylic seems to be the worst possible material for being slick. It seems to grab quite a bit. So I may change that material and do a better mechanical design in the future, where I make this more like a bearing, so it's only on the coil surfaces that it's actually holding on to the rod, and then in the back, in the tube, we have another bearing surface to keep the push rod straight. So that's the kind of thing that a mechanical engineer perhaps could have told me, and I wouldn't have wasted all this time. But before I redesign yet another stator, which it will take me some time to do, I wanted to get this working more effectively. The other weakness of the system is that it's actually not very strong at 12 volts, and I would like someone, maybe myself, to research how to build better coils to make it more powerful, and also perhaps decide if we have to go up to 24 volts. So in creating Public Invention for All Humanity, I'm trying to create teams of inventors that are working in the public interest. This is not exactly in the public interest, but at least it's an invention in the sense that we are trying to create large robots out of inexpensive linear actuators, and this is a attempt to make a lower cost linear actuator. If someone wanted to contribute, there are a number of things that could be done. I think it would be very nice to design better coils, figure out exactly what magnet size, what wire size works best, and how many turns to use to provide the greatest holding force or push force or the greatest magnetomotive force. Another thing would be to make the same system on a smaller scale, which could be pretty interesting, to make sort of a even smaller version of this actuator, perhaps at half size or quarter size. And of course there's design work to be done in the circuitry. This stuff all needs to be turned into an actual PCB design. So there's lots of work to be done. If anyone is interested in that, please contact me. As always, the most important thing in some ways is to imagine what we could do with this. So for example, the purpose of this is really not to create one linear actuator, but to create hundreds of them or dozens of them stuck together, and to think about what we could do with that. And so of course artists, philosophers, thinkers, mechanical engineers could all help with that problem. In particular, we need a mechanical system where both ends can be attached with a universal joint to other Gluss pushers to make the system, which is a non-trivial mechanical engineering problem, particularly at low cost. I have bought a U-joint, but even so, there's plenty of work to do to figure out how we can make this electronics fit in here nicely in a way that we can attach the whole thing to something. So there's lots of work to be done. Thank you.